It makes me extremely happy and sometimes a bit nerve-wracking when you get questions from some random stranger who gets a number from a social platform and kind of makes us question through it straight to WhatsApp. And here's one such question where I've been teaching for years, but I must say that even now certain questions really catch my nerves, and that makes me feel how little I know at times. Let's look at this question. Here we have two different aircrafts. You can read the question in your own time. Two different aircrafts are leaving from X and Y, which are spaced 960 nautical miles apart at different times at different ground speeds. You have to find out the time when the aircrafts would cross over. You must have come across similar questions, numerous of them floating around for most of the aptitude test, and where you have train-based questions, which train is going to cross at this particular point at the shortest time, or what's the crossing point between two different trains. All such kind of questions you must have seen. This is a very similar question and heavily asked for the exam as well. So let's kind of dig a bit deep into it. We have two different destinations, which is like departures as well, X and Y. So let's mark those. So we have X here, and then we have Y, right, which is spaced 960 nautical miles apart. So XY distance is 960 nautical miles. Two different aircrafts, one leaving X, that's aircraft A. So we have aircraft A leaving X at time 12 hours and 5 minutes and at a ground speed of 370 knots. You see how ground speed is largely connected to your ETS and stuff rather than true airspeed, and that's more practically correct. Now look at the other aircraft, which is leaving the departure station Y. That's aircraft B. It's right here. This is aircraft B, and that's leaving at time 12 hours 25 minutes at a ground speed of 290 knots. So we have the data in place. Let's see what the question is asking for. At what time? At what time will the aircraft pass each other? Interesting. Pause this video again, as I always say. Use some of your brain space, your quiet room, and try to figure out the answer. Let's come back and do it together after that. All right, so here we have the question in place in the form of a diagram. Aircraft leaving X at 12:05 with 370 knots of ground speed, and 20 minutes, is it 20? Yes, 20 minutes later. Now look at that particular term there. 20 minutes later, aircraft B leaves at 12:25 with a ground speed of 290 knots from Y. XY spaced 960 nautical miles apart. You have to find out the point of crossover of both the aircrafts. Remember, both the aircrafts are not leaving at the same time, neither are they flying at the same ground speed. Okay, all right. Now I'll tell you a very common mistake that students make here at the very end of this particular problem. But let's see how to do this problem together, assuming that most of you have got this answer. This is a recorded session, not from a regular class. As I said, I just got this question a couple of days before, and since I was pretty much busy with my classes, couldn't really get to it. And finally, I have some time. Let's find out. So aircraft X leaves at 12:05. Aircraft B is stationary, is at Y at that point of time. Let's see. So when the aircraft Y starts its travel at 12:25, it's only 20 minutes past aircraft X has already started its journey, right? Let's see where aircraft X would be when the aircraft Y starts its travel. So basically we are planning to find out the distance traveled by aircraft A over a time of 20 minutes at a ground speed of 370 knots. Pretty much straightforward, right? Speed is equal to distance by time, right? So over here, let's see what is the distance traveled by aircraft A in 20 minutes. The 20 minutes is the time that the aircraft B takes to start after aircraft A, right? So distance traveled by aircraft B in 20 minutes at a ground speed of 370 knots. So we have the basic equation: speed is equal to distance divided by time. You're asked to find out the distance D here, that is speed, which is the ground speed, into time T is in minutes, and make sure you have to convert that to hours here because your speed is in nautical miles. So 370, and that's in knots, right? And you multiply that with time, which is 20. But remember, this is in minutes. I'm a bit particular about the minutes because very simple, but it's very easy to go wrong, right? Think about yourself, how many times you must have made mistakes in making the units in line. Divided by 60, and that makes it to hours, right? This is the hour conversion, right? I'm not writing it here, but basically we divide by 60 to convert that to hours. Now when you do that, now it gets converted to hours. Perfect. Let's find out what this is. It's 123.33. Remember, it's in nautical miles because it's not and in hours, so it's 123.33 nautical miles, distance traveled by aircraft A before aircraft B starts its journey. So let's mark that point here. Say for example it's point P, and that distance is 123.3 nautical miles. Let's keep the decimal places intact there until we reach the final answer and kind of round off. Perfect. Now look at the question. Now what we have is the distance py. That becomes more significant now because from the point P, now the journey of aircraft A and A and B starts together. So the aircraft A is now currently here, right? And this is the time 12:25. That's when aircraft B starts its journey from the departure station Y. Now what is the remaining distance that the aircraft needs to cover? Let's find out. So the total distance is 960. The remaining distance is going to be 960 minus 123.3. So that is 836.7 nautical miles. Now what the question is asking you is to find out the point where the time the aircraft A and B would cross over, would intersect, right? Now what is the speciality of a point of crossover? Now you must have done this in your physics lessons as well. Let's kind of very quickly recap. We have aircraft A and aircraft B starting from points X and Y. Now we have kind of brought it down to a point where aircraft A and B start at the same time. That is distance P and Y. So it's distance P over here, and this is Y. This is the distance that is significant to us because for the initial 20 minutes, even though the aircraft A is flying, B isn't. So we need to have both the aircraft flying at the same time and then kind of find out the crossover point. Now aircraft A, and imagine, would cross over aircraft B at say point here, which is the crossover point C. Alright, now what is the speciality of this crossover point? The time the aircraft A would take to travel to the point C and the time the aircraft B would take to travel to the same point C would be the same. That is why it's called as point of crossover. The distances and speeds would be different, but the time would be same. So what we're looking at in this particular question as well, the time taken by the aircraft to travel from A, and let me mark the same point over here, the point C, the crossover point right here. The time taken by the aircraft A to reach point C from P and the time taken by aircraft B to reach the same point C from Y has to be the same for C to be the crossover point, right? So we immediately got the equation. We have an LHS equaling the RHS. That's the time factor. So the time taken by the aircraft A to cover the distance PC is equal to time taken by the aircraft B to cover the distance BC. Remember, these distances are not the same, need not be the same because the ground speeds are different. Look at the basic speed distance time equation. Time is equal to distance divided by speed. For distance, let me take this particular distance as D here. Since the total distance is 836.7, the remaining distance is going to be 836.7 minus D. Perfect. It's quite simple, right? Let's bring these equations here. Speed is equal to distance by time. Distance traveled by the aircraft A, that is the PC, divided by the ground speed of aircraft A, is equal to distance traveled by the aircraft B, which is YC. Let me make the correction here. It's not BC, it's YC, sorry, and divided by ground speed of B. The distance traveled by PC is taken as D, and therefore the distance traveled by aircraft B, which is YC, is 836.5 minus D. right? The ground speed of A is given the question as 370 knots, and ground speed of B is slower, 290 knots. So it's 370 knots, and this is going to be 290 knots. Now, I kind of thought of doing this equation straight because it's quite easy, but I equally think it is important to kind of do this step by step, because there are at least a bunch of students out there who are quite weak in their basic mathematics, especially in solving such equations involving variables, linear equation kind of stuffs. Let's kind of solve this. Especially this is for those students who fumble with such kind of mathematical expressions. If you are well versed with this, you can definitely skip it out and go to the answer straight. So what in such cases, what you can do is you can straight away cross multiply over here. So it's 290 knots into the distance d is equal to the 370 is multiplied with the numerator in the RHS, 370 into 836.5 minus d. Right now, this is 290 d is equal to 370 times 836.5. You're kind of opening up the bracket and you're multiplying it with every element inside it, minus 370 times d. Now the next point is to bring the variables on one side and the constants to the other side. So this involves two different steps. Number one is bringing 370 to the LHS, that is minus 370 becomes plus 370 as it navigates to the equal to expression, plus d, that is equal to what remains in the RHS is the constant, 370 into 836.5. Now the second part of making the constants to one side and variables to the other is kind of adding these to 290 plus 370, and that's going to be 660 times d, which is equal to 370 multiplied with 836.5. I'm kind of leaving the multiplication to the end. The final step is to find out d, where you have the variable d on one side and all the constants on the other side. See, this is how it's done. Might seem simple, right? But there are students who kind of fumble with this and kind of go wrong just because they didn't have this kind of understanding. That's 468.95 nautical miles. So this is the distance that the aircraft A, because d is the distance traveled by the aircraft A. We put this d straight here. That is 468.95. You can take it as 469. Let me keep it as 468.95 for time being. And obviously now you can find out the distance traveled by the aircraft B. It is just 468.95 removed from the total distance of 836.7. Let's find out that. And the remaining distance over here, which is required to be traveled by aircraft B, is 367.75. I'm just completing the question. You might not need to find this distance. Now, what the question is asking is the time taken, the time at which this particular crossover happens. At what time is it happening? So what are we trying to find out? As you can, the time aircraft A would take to travel a distance of 468.95, or that's exactly equal to the time taken by the aircraft B to travel a distance of 367.75, and you simply add that to 12 hours 25 minutes, and you'll end up the time at the time where the aircraft would cross over. So let's find one of it, which is the time taken by the aircraft A to travel a distance of 468.95. So let's find out. Time taken by aircraft A to travel 468.95 nautical miles. Again, speed is equal to distance by time. See how many times the same basic equation is coming back to back. Just think about the basic equation and kind of derive an expression that relates to the question. So time is equal to distance divided by ground speed. So distance is 468.905 and the unit is in nautical miles, divided by the ground speed. Remember, that's the ground speed of aircraft A, which is 370, and that is the nautical miles per hour. And therefore the equation that the values are in line. That's going to be in hours, and you can convert that to minutes by multiplying with 60. So it becomes 1 hour and 16 minutes. One of the previous videos I have explained how to do this kind of hour to hour and minute conversion using a scientific calculator. Pretty important to learn that. All right. All right, perfect. So now let's see at what time does this crossover happens. You can find the same thing for aircraft B as well. It's going to be exactly the same. Not the time taken, but the crossover time. All right. So the time taken by the aircraft to travel a distance of 468.95 nautical miles is 1 hour and 16 minutes. So this particular distance is covered in a time of 1 hour and 16 minutes. So what is the time of crossover? It's at 12:25, and you simply add 1 hour 16 minutes. So that is 12 hours 25 minutes, and you have 1 hour and 16 minutes. This is how you add it. Let's do that straight here. Therefore, the time of crossover is equal to 12 hours 25 minutes plus 1 hour and 16 minutes, which we got right from here. All right, let's kind of add these two. I hope that step is clear. You're kind of spending so much of time. So it's 25 plus 16 is 41 minutes, and 12 plus 1 is 13. So it is 13 hours and 41 minutes. That's the time when the aircraft would cross over. The time is 13 hours 41 minutes. That's the time of crossover. Let's look at the options here. Option A, option B, option C. That's it. Option A is there, 13 hours and 41 minutes, and therefore Bravo is the answer. Very, very simple question. Now, one point which you have to understand here is framing this particular equation. If you can actually frame this equation here, you pretty much have conquered the entire question. Now, different questions have different equations. It's not always the time is the same, but for questions involving point of crossover, make it a point that at the crossover point, the time taken to reach there is going to be the same, and that is why it's a crossover point, right? Now, a very common mistake, as I've mentioned before, that I've seen students make in these kind of sums is that they forget the fact that the aircraft A took off earlier, 20 minutes earlier than aircraft B. And what they simply find out is, let me kind of manipulate this diagram for time being. They kind of try to find out that the time taken, same expression, the equation is the same, time taken by aircraft A is equal to time taken by the aircraft B. But what time is it? They consider the time taken by the aircraft A from the starting X all the way to the crossover point C, and the time taken by aircraft B from Y to the point C. And I'm pretty much sure you might end up in answer A if you do that. That's because you're not considering the 20 minutes of time where that the aircraft B took to start while the aircraft was still flying. All right, so I hope that particular error is clear to you. Do let me know if this question is not very clear, because I've just rushed through this question because of lack of time. It's already like 11:15 here. So, but I just thought of putting it up because I've been getting repeated queries on the same question back to back. I do have similar questions as well coming up. As I said, when I get time, I'll definitely try to post it up as well. If you have any kind of queries regarding your CPL, ATPL based subjects regarding the theory or the problems, just kind of text me up on Instagram or WhatsApp. I'll drop my number in the chat. My Instagram, Twitter, Facebook links are all there right down. Let me know, and whenever I get time, I'll definitely try to come back with some kind of wisdom. Now, one more thing which I would like to request is, in my videos, I kind of take care that I make the data as proper as possible from whatever knowledge I have. But just in case if you find mistakes, do point it out, do comment it out, or you can just DM me as well. I'll definitely try to correct it and improve the next time. All right, that's it. And for whoever has sent this question to me, thanks a lot, because it's a very, very good question, very popularly asked for the exam. I'll see you with a different series in the upcoming videos. That's it. Take care. Bye bye.